Okay, YouTube, in this video we're going to explore how we could use reference angles in order to easily evaluate trig functions like tangent of negative 240 degrees or perhaps the cosecant of 17 pi 16ths. So in order to evaluate using related angles or reference angles, the first thing we're going to have to do is find the reference angle for any of the given angles that we are taking a trig function of. So looking at these steps that we're going to go through here, let's go ahead and start by looking at this. It says find the reference angle for theta, which is theta prime. So with respect to our first example here, we say the tangent of negative 240. How we would evaluate this is first of all saying that if this is our theta right there, let's go ahead and sketch this out. You always want to sketch a picture. Negative 240 would rotate counterclockwise, and I suppose that would have to go negative 180 plus about another 60 degrees to get to a negative 240. So we would say that our negative 240 degree angle in standard position would be this angle right here. So now we find the reference angle by saying that it is the angle formed between the terminal side of our initial angle and the x-axis. So our reference angle in this particular case, here's our terminal side and here's the x-axis, looks like we had to go 60 degrees past the negative 180 to get to a negative 240 in the first place. So what we're going to do is we're going to make a little note here. For letter A, our reference angle is 60 degrees. So now for step 2, what step 2 says is it says that we're going to evaluate the trig function for theta prime instead. In other words, what we're going to say is instead of doing the tangent of 240 negative degrees, what we're going to do instead is find the tangent of its reference angle. And so the interesting thing about this is this. I'm going to write equals the tangent of its reference angle here. The tangent of an angle and the tangent of its reference angle have to be the same up to a certain point. They have to be the same numerical value. They may not be both positive or both negative, but they have to be the same numerical value. So the nice thing about this is that we know the tangent of 60 degrees. The tangent of 60 degrees really is just root 3. And we can certainly verify that by sketching out a 30, 60, 90 and knowing this. Or knowing this, rather. But we could sketch it out and find it. So the only other thing we have left to do here is this step 3, and it says determine the sign of the trig function value from the quadrant in which it lies. So here's what we get to do, one of my favorite things. Now, I provided us with this chart up here, which is really convenient. And what you're seeing is this. We say, well, you know, sine and cosecant are both positive in the first quadrant. Cosine and its reciprocal are all positive in that quadrant. And tangent and cotangent are positive in that quadrant. Basically, all trig functions would have to have a positive value in the first quadrant here. So a nice way to remember this is we'll just write the word all. Now, to supplement the rest of these, what I'm going to do is I'm going to write students take calculus. You can come up with your own mnemonic here, but I use this one, all students take calculus. And really, the only things I want to use here are the A, S, T, and C parts of this, because what this is going to stand for is all, sine, tangent, and cosine. And what this really is saying is that the only trig function that would be positive in the second quadrant, if you terminated there, would be either sine or cosine. If you look at cosine and its reciprocal, or tangent and its reciprocal, they're both negative here. The only thing that's positive up here is sine, whereas when we look down in quadrant 3, the only thing positive down here is tangent. So we have tangent, or T, or the T quadrant here, tells us that tangent's positive, everything else is negative. And when you look down here, for all students take calculus, this is our C quadrant, this tells us that cosine and its reciprocal are the only trig functions that will be positive in the fourth quadrant. Everything else will be negative. So what I want to point out here is this. Step 1 was find the reference angle. Okay, we sketched it, we found a reference angle, and we decided to use the reference angle instead. Then step 2 was we evaluated the tangent at that reference angle, which we were able to do. So the step 3 just says determine the sign of the trig function value from the quadrant in which theta lies. So when we're discussing theta, we're talking about the initial angle here. And that initial angle, if I said, well, where did it terminate? Which quadrant? Looks like it terminated in quadrant 2. So because this terminates in quadrant 2, and we are finding the tangent in quadrant 2, then using our mnemonic here, this all students take calculus, we could say that because we were finding tangent in the second quadrant, it must be negative. And the reason why is because only sine values are positive in the second quadrant. So let's take a look at letter B here, the cosecant of 17 pi 6. So what I want to do here is this first step, which is let's find the reference angle. So this cosecant of 17 pi over 6, what we're really going to do is find the cosecant of its reference angle first. So 17 pi 6, let's think it's positive and it goes in a clockwise or counterclockwise direction. If this is pi and this is 2 pi, if we convert these to sixths, I suppose we would have over here 6 pi sixths, and over here we would have 12 pi 6. So 17 pi 6, what we can determine is 12 pi 6 plus another 5 pi 6, which would have been a pi 6 short of 6 pi 6. So here is our angle right here. So here is our 17 pi 6 rotation. What we want to find is the reference angle. And remember that the reference angle is just the angle between the terminal side of the angle and the x-axis. So if this is right here, the leftover, what we need to be able to say is then that's got to be a pi 6. The reason why is because 17 pi 6 was 12 pi 6 to begin with, plus 5 more pi 6, which was a pi 6 short of where 6 pi 6 would land. So here's what we know. The cosecant of 17 pi 6, I suppose I'll just write this up here, is the same thing as the cosecant of just pi 6. So now, with the cosecant of pi 6, the thing here is we're going to need to find the sine of pi 6 first. Because we know the cosecant of pi 6 is the same thing as 1 over the sine of pi 6, they're reciprocals, then we could say that the sine of pi 6 or the sine of 30 degrees here, sine of pi 6, which is the same as the sine of 30 degrees, that is a half. So the cosecant of pi 6 is going to be its reciprocal. Cosecant of pi 6 has got to be 2. So what we're going to do is we're going to go up here, we're going to say, okay, all of this right here is equal to 2. The only thing we have left to do is go back and determine whether or not we should make it positive or make it negative. So in this case, what we were finding was the cosecant, which is the reciprocal of sine. And using our all students take calculus mnemonic here, we would know that if the sine is positive, then the cosecant is also positive. Our function terminated in the second quadrant, so because sine is positive, then its reciprocal cosecant is also positive. We will just affix a positive 2 here. So the cosecant of 17 pi 6 would have to be the same thing as negative, or pardon me, positive 2.